G'day, let's have a look at this Milwaukee work area floodlight. Now this is an M18 platform, and the distinctive feature of this light is the head that comes forward, so you can pivot it up and down, and you can also rotate it any way that you want. So it almost goes 360, it'll go all the way around this way, but then this way it stops at this angle here. And it's got about 180 degrees rotation this way as well, so it might be a little bit clearer to show that way. As far as mounting for this light's concerned, is it's got really strong magnets here, so you can mount it magnetically to any magnetic surface. This is just a screwdriver, obviously you're not going to mount it like that, but just showing those magnets for reference. They're really strong. This has a 5 amp hour battery on it, and it doesn't really have a problem holding that on there. And then the other thing that it's got down here is you can put this little tab out, and this whole little handle comes out, and then it's got a really strong spring that it just pulls it right back in. So what you can do is you can put a piece of wood or something here in between that, let that stick, and then that'll just hold itself up wherever you need it to. And then while that's getting held up, you can then adjust the head to point that any way you want and light it up. As far as the lighting modes, you just press the on button there, and it's got I think it starts off on low, and then you've got high, medium, and then low again. So just those 3 different modes. High, medium, low. And then to turn it off, you just press the off button there, or the on-off button there again. And on the back, this is, as I said, a 5 amp hour battery, and it fits it really well, so it doesn't stick out of the actual light. But if you put a bigger battery on here, it might stick out. So depending on how you want to actually mount this light, a bigger battery might not work too well. And the battery just slides in, and it's nicely protected by these extra protrusions on the outside. It does also have a nice handle as well, so you can carry it around or perhaps even mount it that way. So there are a few screws out the front, and it does also have screws down the back here everywhere. But I would imagine that it's just got the actual LED lights and a heatsink out the front, and then the driver and the actual on-off mechanism would be in this back box here. So to start, maybe we can just take these front screws off and see that actual LED, or see if that comes out. Alright, so I think we've taken this bit apart enough. So it's just all of these plastic injection molded bits that hold the actual PCB and the big heatsink together. There is this, I think it's almost double layered, maybe it's not, maybe it's just quite thick. So it's probably about 2 to 3 millimeters thick, this plexiglass on the front that actually protects that LED from any impact or debris or anything like that getting in. So that mounts straight onto the front, and then it just has this little plastic, this is all just plastic painted sort of this grey colour to make it look a bit more like a metal texture. And that just sits on the front to hide these screws on the actual PCB there where the LEDs sit. And then we just have this back cover that sits in with the front cover, and the front cover has a really nice, so it is just a hard plastic, and then it's over molded with this really nice rubbery texture. So this is quite grippy, and I think that would have just been done for a little bit of impact absorption there as well. And then on the inside, we've got a really nice O-ring going all the way around. And then on top of that, there's a lot of grease covering this as well. So I'm not actually sure if this does have a waterproof rating, but by the looks of it, this is at least water resistant. So if you splash a bit of water on it, I don't think it'll actually damage it. So that's it. And then here we just have this whole bit is the actual heatsink. It's just extruded aluminium. It's got these really nice ribs in the back that increase the surface area, so the heat can dissipate from that. It's mounted to a metal bracket, so that's just a pivot joint there. And then on this side, we have the white PCB with 5 little LEDs on it, and then just 2 wires going into the inside or the rest of the actual case, where the LED driver and the power control is going to most likely happen, because it doesn't happen here. This white stuff is just thermal paste, so it's good. It's seeping out pretty much everywhere all the way around, so that's really good to see. So for this PCB would be making really good contact with the heatsink in the back through that thermal paste, so all of that surface area would be able to conduct the heat onto the heatsink. The only thing though is the back of this heatsink is actually just covered by this plastic, so this just sits right on top. There's no ventilation or anything like that in here, so this heatsink, although it's good, it's quite a large one, but it doesn't really have anywhere to vent, so the plastic won't conduct heat that well, but this will just get very hot as that heatsink absorbs as much heat as it can, and then it would slowly dissipate out of the plastic or through the plastic out into the environment. So don't know how they could have done this differently, but it would have been nicer to see this exposed to the environment, to actually not have an insulating layer of plastic on top of that. But maybe this plastic is just ABS plastic, yeah. I was going to say maybe this plastic is a special type where it conducts heat really well, but I don't think it's anything special. It's just standard ABS plastic there. But again, obviously Milwaukee would have designed this to be sufficient for however long this operation needs to go, and the LEDs themselves probably wouldn't produce that much heat to need any sort of active cooling or more cooling than what they have. Again, I'm just taking it apart, having a look. They were the ones designing it, so I'm sure they designed it to the right specs. Alright, so while we've got this open, there's 4 screws on the front here, and then there's a couple more screws down the bottom there, and this all looks like the same bit of plastic. So I'll take them all off and see if we can open that up and see what's inside there. Alright, there we go. That all just snaps open. This L-shaped bracket there just holds it all together. So let's have a look at this first. I guess this is that whole assembly. I'm trying to hide this. For this arm to pull this out. So sturdy metal, we've got 2 guide rods, and then we've got 2 very sturdy springs there. And just inside there, there is an actual little spur wheel. That's just going to be providing that resistance, or a bit of a damper actually. So when you pull it, the springs will provide resistance, but then it'll go out slowly. So if that wasn't there, the springs would just shoot it straight back out. Whereas that little spur wheel would probably just have a little pocket of oil inside it just to act as a damper to limit that motion. So if I move this out the way, you might just be able to see me pull that. I just have to hold this down because this is quite a strong spring. So pull this arm out here and then let it go, and you can see that slowly spring back. Alright, cool. So that explains this whole big case in here, or all this space in here is taken up by that assembly there. And then we just have 2 cables. So we've got 1 cable coming from the bottom, which is just going to be from that battery terminals on this side here. And then we've got 2 more cables, and they just go straight into the LEDs. So that's all we've got coming in and out there. And here we've got the brain box just behind this red cover held down by 4 screws. So I'll again keep going into it and see what's in there. Alright, so that pulls the PCB out. And one thing I do got to say is this is actually quite annoying because there's 2 different types of screws. There's slightly smaller ones and then bigger ones. And there are Torx. I think there are Torx 7 and Torx 8. So just got to keep swapping between the different tools to take different screws out. And this one is a Torx 6 that actually holds this PCB together. So they're all normal Torx, they're not security Torx. But you need a 6, 7 and an 8 to actually get into this. Let's see if I can actually just get this out. So I think this definitely does have some sort of waterproof rating or IP rating, because this PCB is in its own little case that's completely sealed there with the wires coming out, and then the other side sits on this pad, which is just a rubber pad that waterproofs it from that end, and the buttons just push straight through that. And the PCB as well has really nice conformal coating, so I think this has some water resistant ratings. So I try not to break all of that because it is actually really difficult to get it out. I've already pulled the little pins out over here. So it'll still work fine, but I don't want to pull that out and then pull the whole PCB out. So we'll just have to look at it at a bit of an angle We just have a ferrite core inductor over here, so that's just going to be acting as a low pass filter, filtering out any power coming in from the battery. A few capacitors, so 1, 2, 3, 4, 5 different capacitors here on the input side. So we're probably going to have a switch mode power supply that actually powers the light there and probably controls it through PWM. So the reason we've got all these capacitors here is just to provide filtering for all that power, just for all that switching, just to smooth out the power. What's nice to see is we do have this elastic, sort of a really hard silicon actually, that's just sitting next to that inductor there, actually holding it all in place. And then we've got a little bit more with these two capacitors here and a bit more on this side. So that's really good. That's just holding all those components nice and sturdy as this thing gets thrown around. But that's pretty much it on that side. We can't really see much more, so I'll just put this back before I pull those pins out and break it even more. And then on this side, I'll bring this up a little bit closer to the camera. Alright, so what we've got here is we've got the two switches. So one will be for on-off, the other one will be for mode. Then we're going to have a little microcontroller here that's going to actually be doing, that microcontroller there is actually going to obviously control this whole thing. There's another little controller there, and then we've got a transistor here. So that transistor there is going to be turning on and off in order to actually switch the LEDs on and off to control that different brightness. So the way that's going to happen is there's going to be a PWM signal passed into it. So pulse width modulation is what it's called. So it basically just means if you want the light to be at 50% brightness, then this is going to be on 50% of the time and off 50% of the time in a really short duty cycle. So it'll effectively turn it on and off really quickly and be off half the time and on half the time. So the microcontrollers here would be controlling that. It's about all we've got. I mean, there's a lot of other small little voltage regulator, capacitors, resistors, a couple of diodes in place there as well. So they're all just going to be supporting electronics for the microcontroller, the buttons, pull-down resistors, and so on. There is actually also a nice diode here, so it's quite a nice size there. So that'll just ensure the power only flows one way into the light from the battery and no surges come back. But that's pretty much it. Nice and relatively simple PCB to do all of that thinking there. So have another look at this, but you can see how much space is just empty here. So obviously this mechanism does take a lot of space, but there is still quite a lot of empty space on the side. So not sure what the thinking there was. I think they could have made this more compact, but maybe this was just easier for assembling and the way that was done. The other thing to point out here as well is we've got this. So we've got this pivot point here for the actual LEDs on the front. So you can see that pivots, but then we've also got this pivot here as well. So these are all really nice sturdy pivot joints and they don't move around unless you put a lot of force on them. So there'll be a nice damper in there, or perhaps even just a rubber holding that shaft together to provide that damping there. We just have another ferrite here as well, just to basically get rid of any high frequency that comes on that line and just filter out the power signal there. So I think that's it with this one. There's a lot of screws. This makes quite a big mess to actually take it apart and need quite a few different screwdrivers. But that's it. That's what's inside a Milwaukee Floodlight. So I hope you enjoyed the video. If you did, hit that thumbs up. And if you want to see more of this sort of stuff, then consider subscribing. So thanks. Have a great day.